Hi there! Today I'm going to show you how to implement controllers and other input devices using Unity's new input system. It is easy to use and much more powerful than the old input system, allowing control schemes, customizable input, and multiple controllers. So I have created here an empty project with a simple sprite here as the player. By the end of the video, we're going to be able to move the sprite using a controller or anything else really. To start, we're going to have to open up the package manager and install this input system here. So just click install and it'll get installing. Okay, this pop-up will come up, just click yes, it'll disable the old input system and make sure that the new one works. Now this will restart Unity, so you will have to wait a bit. Okay, Unity is reopened. You can see if we go down here to the input system, it's now been installed. Okay, great. Now let's create our control scheme. So you're going to want to right click, go to create, and then go down here to input actions. We'll just call this input controls. And now we have this input action asset. What we're going to want to do is go to edit asset, and this will open a new window. We can dock this, so I'm going to put it down here. As you can see, there's 3 tables here. The action maps, the actions, and the properties. We're going to start by clicking on this plus here by the action maps. So what an action map is it's a series of controls that you'll use at a certain point in time. For example, we might use this one during gameplay. You might have another one during a menu or some other scenario. So each of these action maps has a list of actions. This will be stuff like, for example, move or, I don't know, shoot. And you can see here the properties of the actions. You can also open up the actions, and these will be the triggers for the actions. So we're going to want to delete this binding here. We're going to want to go to move. Since it's not a button, it's a value. We'll check the value part here. It'll be of type vector2, since we'll be moving in 2 dimensions. And then on this plus by the move, we're going to add a 2D vector composite. Now what this does, it's kind of like a build your own D-pad. You've got all these directions here, and now we're going to tie keyboard keys to them for now. For now, we're going to test with keyboard keys. Later, I'm going to show you how to do it with a controller. Okay, so we have our 2D vector composite. We are going to go to the path here. Here are all the different types of buttons. We'll get more into those later, but you can just click listen, and if I press W on my keyboard, you'll see this pop up here. So right now I'm just going to quickly input W, A, S, and D for some quick testing. Okay, we have W, A, S, and D. This will do now for testing purposes. So what you're going to want to do is click Save Asset here. If you don't want to click Save Asset every time, you can also click the Auto Save here. I'm going to leave it off. Okay, one last thing. Here by the input controls in the inspector, you're going to want to click Generate C# class and hit Apply. Now what this will do is it'll take all of the controls you gave it here in this window and turn it into a C# class that you can use very easily. Okay, now let's get to some code. We'll go here to the player and we'll add a script. We're going to call it player movement. Okay, I'm going to open the script in Visual Studios and we'll get to the coding. Okay, here we are in Visual Studios. We can also see, if we go into the assets here, we can see the input controls that has been generated. This is all the inputs that it took from that one table. It'll get bigger, of course, the more stuff you add to it. But the good thing is it's done automatically. You don't need to touch anything here. You can just ignore it. Okay, now that it's cleared up, we're going to want to create an input controls. We'll just call it controls. And on awake, we're gonna make controls just equal new input controls. Okay, now let's create a vector2 here called movement direction. And the idea is we want our input system to change this value because we are going to use it in the update by using transform.translate. Okay, so the way we do this is by doing controls dot, and then we look at our input controls here. Our action map is gameplay, so we do controls dot gameplay dot, and then we want to look at the action we're looking at is move. So we do dot move and then dot performed. So when this move action is performed, we're going to want to change the movement direction. The syntax for this is a bit weird, but we do plus equals ctx. This can be anything you want to call it. This is the callback context. Then you do equals and greater than to make an arrow. This is a lambda expression. And then we do what we actually want to do is the movement direction equals, and then we take the callback context and we do dot read value of type vector2 in our case. And boom, now every time we perform the move, the movement direction will be this value. We also need to make sure that when it's cancelled, so controls.gameplay.move.cancelled, we do the same, but just turn the movement direction into vector 3.0. Okay, now we need to make sure that the controls are actually enabled, so we do controls.enable. If you want, you can enable or disable them on enable or on disable, but for now this will work, so let's try this out. Okay, and there we go. We have our player zooming around. Okay, there's one more action that I want to do. I want to make it grow and shrink. So let's do that real quick. The way to add another action is just click on the plus up here. We'll call this action grow. And for now, we'll just give it the binding of the up arrow. And then I'll add another action called shrink, and I'll just give this the down arrow. Okay, make sure to hit the save asset button, and let's quickly implement these. Okay, so here we do controls.gameplay, and this time we do .grow.performed, and then we're gonna want to add a function to this. We'll just call the function grow. Let's add it. Now, instead of doing the stuff with the callback context, you can also do it here. I mean, if you wanted to, you could just remove this callback context and do something like this. The choice is yours. Either way, I'm going to implement this growing and shrinking. Okay, now the player will grow or shrink 50% whenever we press the according button. Mind you, we don't have to do anything with cancelled since we only care about when the button is pressed. So let's try that out. Okay, I can still move around, and now when I press the up arrow I get bigger, and when I press the down arrow I get smaller. Okay, great. Now let's implement this for the controller. So first things first, I'm going to connect the controller to the computer. Mine works wirelessly. You may need to connect yours via USB cable. Either way, the way you check if your device is properly inputted is you go to Window, Analysis, and then Input Debugger. Here you can see automatically we anyway have the keyboard and mouse already there. So let's connect the controller. Okay, great. Now the controller is connected. You can see here, you can also open the device debugging view. Then you get this window. If we make this a bit bigger, we can see that when some of these buttons are being pressed, for example up here, you can see the value is changing. Okay, let's put this to good use. Okay, now let's add the controls. So here to the move, we just need to add another binding here. This doesn't have to be a 2D vector composite because with the controllers, they have dedicated joysticks that you can use. So here I'm going to click listen, and now if I use the left joystick. You can see that pops up there. I'm going to use this one. If you wanted to, you can always go to the gamepad. This will usually be the one that works for all of the devices. Maybe not for some third-party controllers like mine is, but for the majority of use cases, you're going to want to use the gamepad. So the same goes for the grow and shrink buttons. Here we're just going to add binding, click listen, and whenever I press this button here, I would like to have it grow. And whenever I press this button here, I'd like it to shrink. Okay, let's save the asset. And that's all the work that should have to be done. If we click play, it should work. Okay, now you can see the players moving around. With no extra work, we didn't need to change any code. We just needed to add the controls. And it also works with the buttons that it grows and shrinks. Okay, that's great. Okay, let's create a new action map. We'll just call this look at, and we'll still use the left stick, but you could theoretically do the right stick as well if you wanted to. Whoops, I forgot to change this into a value of type vector2. Let's try that again. There we go. Okay, let's hit save asset and do some code. Okay, here's the code for rotation. I've also had to change the transform.translate since that doesn't play too nice with the rotation I've got going. But anyway, if we click play now, it should work. So we can see now, sweet, I can move and it'll automatically look in the direction I'm going. Now we could probably hook this up to right stick or anything if you want, but I'll leave that up to you. You'll also see that the player only moves as strongly as I tilt the stick. So if I tilt it all the way, it'll move the maximum speed. But if I tilt it only slightly, the player will only move slightly. This is something you should probably pay attention to. If you're not aware, you can just normalize the direction. So you can do something like movement direction dot normalized, and it'll fix that. So now, for example, the player will always go at maximum speed regardless of how much I rotate it. It's just a thing to consider. Of course, you can play around with this as you could with any other input settings. But that's it. Input is very easy to do, as you can see, and it's very modular. It's very easy to add new stuff here. You just create new bindings and attach the controllers. You can do it with you can have multiple buttons trigger the same event if you want to among different controls, which is what makes it great. If you want, you can even annotate your bindings properly. You can create these control schemes, like you can say, oh, this is going to be for the for keyboard and mouse, and you can create another control scheme for your gamepad, for example, and then you can always just check your according thing. So your 2D vector composite here, this is all going to be keyboard and mouse. And the cool thing is that now this will hide when you're only looking at the gamepad, and if you're looking at the keyboard and mouse, it'll only show that. So there's a bunch of cool new settings you can do with that. Great thing is it works among all devices and all the controllers. If you want to do stuff with the touch screen, for example, like let's say you want to add a joystick, you can always add the on-screen stick component, and if that's on a proper joystick, it'll actually treat it as an input device. But yeah, that's everything. I hope you guys learned something today. If you liked the video, hit the like button. If you really liked it, hit subscribe and ring that bell. It means a lot and it's free. That's everything. Thanks for watching.